Thank you for coming. It's going to be like one of the last talks, I'm sure. So thank you for sticking with me. It'll be 2 case studies that I wanted to share about enterprise use cases using data sharing. And I think if you went to the keynote this morning, you might have heard Karthik talk. My name is Teresa Tung. I'm from Accenture, where I lead our global data capability. And we see much more of a demand for confidential computing than ever before. I know this technology has been around for a while, and I would say the need for AI and the need for data sharing, people have understood it, but it hasn't been a top line priority, right? So CEOs, the board of directors are asking their teams, what are you doing with AI? And then from that, they need to see, well, what sort of data do we have? And very quickly, we find that enterprise data is not ready. There's not enough of it. There's not good quality. There's not safe ways to exchange the data. A lot of these generative AI use cases that people have in mind, it's very easy where we talk to these companies, and they've gone through use cases where, again, from a board level directive, from a CEO perspective, they've mobilized the whole company to look for use cases, right? All sorts of use cases, and people are so excited, right? So a lot of people, they're so proud. They're like, I found 127, some large number of use cases. The problem with that is they are lacking the data to do any of the work. And a lot of these use cases are cross-functional use cases. That means they cross different parts of the business, right? So even to look at a whole picture of a customer, what we call customer 360, you need to look at the customer from the perspective of prospective customers. You might look at customer transactions. You might look at customer service. And sometimes these are usually in different functions. So even to be able to have that holistic picture of the customer, you require all these different parts of the business where they might not be set up to share data or might not make it easy to share data. I'm right here, so I guess I don't need the clicker, but So, when we're seeing these emergent risks with data sharing, I think by this talk, you've probably already seen what the risks are, but let me just build it out for you. So number 1 is your intellectual property leakage. So Karthik shared this morning one of the use cases with an industrial manufacturing monitoring company, somebody who puts equipment within data centers or within factories. And this equipment manufacturer, they're monitoring and they're looking at improving the cooling, improving the power of buildings, right? Large data centers and large buildings like this hotel. As they do that, their customers are demanding AI. Like they say, I hear about this AI stuff, right? And they want to buy AI. They don't want to share data. But 2, this company also doesn't want to share their IP. So they say, give us your model, and then I'm going to run it for you. But by giving them the model, you're also giving away the whole reason that they would license the software in the first place. So I think that's one risk. The second one, as I mentioned, is data fragmentation in silos, right? I mentioned being able to even just see 360 of a customer. Even within a company, these are different parts of the business, much less if you're working with partners, right? Upstream and downstream partners to get that full view of the customer. You now want to work beyond your company. So the fragmentation of silos is another. And how we've traditionally gotten over this one is by tokenizing and masking the data, right? We know that generative AI has new risks when even you tokenize and mask. Now, because generative AI can help undo some of that capability that you had just put in to mask that privacy. So generative AI is actually used as a weapon to be able to undo some of those protections that we had in place. Generative AI is used to create deep fakes that are tricking people into being able to share their data mistakenly. So that weaponization is another piece that more than ever, generative AI is accelerating these risks. It could also be just, an accident. People aren't, I don't know why it went forward, but it's making an accidental move to be able to, anybody who can download LangChain, suddenly they're like a generative AI startup. And so that ability to now create this capability, and you share data with this startup or somebody in the company who's just started to play with generative AI, that's great that they're experimenting. But the risk is that when you give them your data, you're also putting yourself at risk. You could bet even the biggest companies like ChatGPT, right? When Samsung used ChatGPT and they had data leakage through that capability, that developer who did that was probably a hero for a week until that risk was found out, right? So if even the biggest companies like ChatGPT have this sort of capability, that's another case for risk. And finally, the evolving geopolitical standards, right? We know that there's a lot of new standards coming out, and so being able to keep data where it's at, making sure that it's protected as companies and as engineers and data users, right? We need to make sure that we're playing a role there. So with that landscape in mind, I wanted to share 2 use cases, right? The first use case is being able to create a bigger picture of data to be able to protect all of us. So this is telcos working together. And you can imagine that there's a lot of risks, right? We're being attacked pretty much all the time with some of these cyber threats. And to be able to see the whole picture, you can't see it as a single telco, right? Some of these large denial of service attacks, and there's like really some sort of ghost pushing that that's, maybe I'm being attacked as we're talking about. I plugged in this USB, but you want to be able to have a complete view of the picture, right? So being able to see these attacks as they're forming means looking across the different telcos. One telco might not be able to see it all. And so to do this, I guess we'll just go forward. Somebody wants me to go, right? Is that we work with Opaque to use some of their confidential computing capability. Right, so one is that each of these member telcos, they could encrypt using their own key the data that they have. And in this case, it might start with really easy. Can I see the same IP addresses? Can I see the same attack patterns? Right, so it might start without a lot of AI, right? Just by seeing the same things is already quite good. So they're going to add each of their encryption keys. Number 2, then that data is going to be brought together and shared as agreed upon all members. So we might be looking at these patterns that we're trying to detect. And that confidentiality is protected throughout this whole process. So it's like you're cooking without being able to see the ingredients, and you're following the recipe that we've all agreed upon. And then finally, then the output is then sent back to the users. So this has a really great benefit. I think one is being able to protect the data, but then 2 is when an insight is found, right, we can actually see the logic that was run, the recipe that was executed, in my analogy, the data that was used, and being able to have each of the parties control, right, how they want to decrypt and see that data. So this also impacts things like eventually for monetization. Why would you share data? One is to see things for common good. Yes, let's protect us together. But another part might be to monetize or to have a particular responsibility for contributing that data or the model. And so this is another way that we're looking at this. I'm going to share one more case study. This is the large German automotive that Karthik talked about. And this German automotive, they are one of our first users with generative AI at scale. So part of this is they have a lot of data that they've allowed generative AI to use. So it started within things like their R&D, within their IT and the code itself, within things like customer service. So as they're using this for generative AI, one is that when you're working within just one part of the business, maybe that's less worrisome about security. So if we started within IT service desk, so every time you call and you need help with one of these applications, that service desk tickets was one of the first things we did. And we got productivity improvements. We had 6 hours of work. With generative AI, we brought it down to 35 minutes. So already got value there. But then we wanted to use that same IT ticket data for other things. We talked about the dealers. So one is the dealers want to be able to use this data because they can, that's the reality of the service of the orders and things that they can use, right? So it's a great thing. But then when they started to use other data outside of IT service desk data, so things around your dealer data and your customer data, now things became more risky, right? You can't share some of this customer data across dealerships. So if I bought my vehicle from one dealer, or if I'm getting my vehicle serviced from one dealer, I certainly want to be able to have that dealer be able to work with me as a customer. But generally, they shouldn't be seeing things across dealerships. So as we added this other type of data, it became much more important to add protections for that. And so in this picture here, one of the use cases is to allow this corporate data to be used by these sales representatives that sit in different dealerships. And as they did this, like one of the things that you might want to prompt is to say, I want to make a change order to a particular order. And so part of our implementation is using a knowledge graph. So the domain knowledge graph is adding very contextualized information to this particular prompt. So I'm saying who the specific dealer is, what's the vehicle identification number, which is identifiable, what's the issue at hand. In this case, there's a scheduled for production maintenance, right? So there's an issue at hand. And so that is then encrypted using opaque, right? And then sent within the gateway. And then in the gateway, then we can strip out a lot of this personally identifiable information with a tokenized version, right? We just need to know there's a dealer number. We just need to know there's a vehicle identification number. We need to know there's an order number. And then this can then execute within the LLM that can give us a response, right? That the order is in production, so there's no changes to be made at the time. And then finally, it's going to go back, and we can add back in. Now it's under protection, so we're adding back in that identifiable information, and then it comes back to the user. So this particular switchboard is a really good place to put the gateway, right? So we can use the switchboard for other purposes. So in addition to security, we could look at this for better optimizing the queries. So if we've done a query in the past similarly, we could have that cached there. We could look at different large language models under the hood to be able to find and route the model that is most accurate for what I'm looking for. Possibly if there's preferred models in terms of cost and accuracy, to be able to all do that within the switchboard. So this is another sort of use case that we were able to apply. So I think in these two case studies, the last points that I want to make is that we want to rethink our data in this age of generative AI. And the confidential computing and working with opaque really does give us a turnkey solution. A lot of how we would have done some of these capabilities before using differential privacy or some sort of masking, that was all very algorithm specific or data specific. Now being able to have something that's saying, I'm just going to share this data. I don't need to know how I'm going to process it in all the different ways ahead of time. That's actually really powerful for the data supplier, right? So it's having us change the conversation. So changing the conversation where I can't share my data to one where I can securely share my data, but for the right use cases. So people are still not going to encrypt everything and then push it into ability to do AI, but the conversation's no longer no. And I think that is a benefit both of the technology, but also of the attention that generative AI has given, right? The conversation starts with, what are we doing with AI? And so people want to have an answer. The second one is, I don't have enough data, right? So I mentioned right in the beginning that typically we don't have enough data to even see, much less do AI, to see end-to-end what I'm doing by ourselves. And so being able to now unlock that trapped value, whether it's AI or being able to see a unique viewpoint in a secure way. So I might not need to see the exact parameters, but I want to be able to see, does it actually exceed a particular threshold? Is this particular pattern detected? I really have no idea where this is going. And then finally, I can't access the infrastructure. So we know that with training a lot of these large language models, we're going to need to use GPUs. The reality is that the reason why NVIDIA stock is doing so well, right, is there's not available, right? It's very hard to get GPUs. So with that in mind, being able to use the cloud and shared infrastructure would be great. But part of why you might be training or fine-tuning your model in your first place is because you have proprietary data that you may not want to be able to put to these shared environments. So being able to use something like confidential computing, even through the encryption phase, but certainly in the inference phase, is another way that we can change the conversation of what we knew before. So I think with that in mind, those are the things that I want to share. If there's any questions, I'd be happy to take them. And I've never seen this sort of slides drive itself, but would love to know if security experts can tell me what's going on. And that's it. Thank you.